So, now we will study the concept of the drift velocity. Basically, how does current flow through the conductor? Suppose we have taken a part of conductor like this, and this conductor is not connected with any battery or a cell. It means there is no potential difference across the ends of this conductor. So, this conductor has got here the large number of free electrons. These electrons have thermal velocities at room temperature, and these electrons are moving in random direction. When these electrons are moving in random direction, so if you assume any cross section area of this conductor, you will find net charge flowing through that area is 0. That means there is no current. Suppose there are n number of electrons in this. If there are n number of electrons in this conductor and their velocities are suppose u1, u2, u3 and un. When there is no connection of the battery or no electric field, we can write here U average is equal to un plus u2 plus un divided by 0. So, if there is no this one, so this average velocities of the electrons are 0 because of the random motion of the electrons. Now, let us consider another case of this. Suppose this conductor is connected with the help of the cell, that means an electric field is set up. Suppose this conductor is like this is here, and this is connected with the help of a battery like this. This is plus minus, an electric field is set up, direction of electric field is to this side from positive to negative, this end is A, this end is B. Now, this conductor has got the electrons, free electrons, which will start moving towards terminal A. Now, when electric field is acting here, the force acting on each electron can be given F is equal to QE, and so we can write here M into A is equal to minus EE, minus is the charge of the electrons. So, we can write A is equal to minus EE upon M. So, now each electron has got acceleration this much, but see here there are the large number of electrons in the unit volume. So, when these electrons move, collisions of the electrons takes place. U1, U2, U3 and Un are the velocities of the electrons at room temperature. So, now when the electric field is applied, in that case, suppose now the time last from the first collision is suppose tau 1, then the velocity gained in this time interval is here. We can write V1 is equal to U1 plus A tau 1. Tau 1 is actually, we can say here also, this is a time interval between two successive collision of electron. So, similarly, V2 for another electron we can write U2 plus A dot here tau n. Now, there are n number of electrons. So, we can write here Vn is equal to Un plus A tau, here that was 2, here that is n. So, drift velocity is actually the average velocity of these electrons, average of these velocities, or you can say drift velocity is actually here average velocities of the average velocity of electron with which these electron move opposite to the applied electric field. So, now we can calculate the drift velocity with the help of this one. So, we can write here Vd, that is drift velocity, is equal to V1 plus V2 plus Vn divided by n. Put all these values over here. So, when we put all the values which we have written in this equation, we will be getting Vd is equal to U1 plus U2 plus Un divided by n plus, here we can write A here tau 1 plus tau 2 plus tau n divided by n. Now, this is 0 due to random motion. So, we can write here Vd is equal to A, this is tau. Tau is this thing is here, this is average time intervals between successive collisions of the electrons, and this tau is known as also relaxation time. So, we can also write here Vd is equal to minus E tau upon m. So, this is the expression for the average velocity of the electrons, and we can also write magnitude of drift velocity is equal to E tau upon m. So, this is the average velocity with which the electrons move opposite to the applied electric field.